Well, it had been mentioned that L'Hopital's rule should also work if we get a form in which we get infinity over infinity. And of course, we certainly see that if we let x tend to grow without bound for the numerator, we are going to get an infinite value. And letting x grow without bound, infinity minus 1 is still infinity. Again, we get this indeterminate value. So supposedly, L'Hopital's rule should work. Right, so this is a job where we're going to take our derivative of our numerator and divide it by our derivative of the denominator before reevaluating our limit. So let's see what's going to happen right here. I take my derivative of the square root of x squared plus 1 using my chain rule. Right, by the chain rule right here, remember we're going to be taking the derivative with respect to x of x squared plus 1 to the 1/2. That's supposed to be a 1, not another parenthesis. Just came out funny looking, that's all. Alright, so by the chain rule, what's going to happen? We're going to get 1/2 times the quantity x squared plus 1 raised to the negative 1/2 times the derivative of the inside of that function, which is 2x. So rewriting this again, we're getting x divided by the square root of x squared plus 1. And in our fraction right here, the denominator, we're getting 0. So we're in fact getting 1. Pardon me, the derivative of the denominator is 1. So it's like saying we're getting x divided by the square root of x squared plus 1. Huh. Well, we're going to get infinity over infinity this time. Now what? Well, let's see. What else could we say? In this case, let's try it again. We're going to take our derivative of our denominator. The derivative of the denominator is the same as the derivative of the what we just did before, right? Because if we take that derivative right here, what's going to happen? We're going to get this again. So we're going to be taking the limit as x approaches infinity of, let's see, 1 divided by x over the square root of x squared plus 1 again, just like we did before, only this time we've just flipped that fraction around. And one suspects that something's up because both of these are just going to go back and forth now over and over again. Does that mean L'Hopital's rule doesn't work? Well, the answer is no. L'Hopital's rule will work, but it's not always the most effective method. Right? So we do want to make sure that we understand that. How do we handle this? This is one where we need to go back to one of our algebraic tricks again. Is there some clever form of 1 we can use to rewrite this? And of course there is. We're going to multiply by 1 over the square root of x squared. Uh, 1 over the square root of x squared. Why? Well, let's look at what's going to happen right here. This is the kind of expression where we take 1 over the square root of x squared, and we're going to get x squared in the denominator. Of course, we're taking the limit as x goes to square root of x squared. And we're going to multiply that in the denominator, only look a little bit different when we do so. If we take the limit as x goes to infinity in the numerator, we're getting a square root of 1 plus 1 over x squared when we distribute that 1 over x squared into the radical of the numerator. Whereas in the denominator, we're going to get x times 1 over the absolute value of x. Now, as x goes to infinity, right, we're going towards positive infinity, so we can say that absolute value of x is equal to x. So we don't really have to worry about that. These guys are going to cancel out, and so we're going to be getting the square root of 1 plus, as x goes to infinity, 1 over x squared goes to 0, divided by 1 again. Well, we get 1. This is a method that we covered earlier. L'Hopital's rule, it works, but only in the cases where giving us a value in the numerator denominator is a certainty. Right here, this is going to go back and forth. So you can certainly recognize that there are times where we cannot use L'Hopital's rule.